All of you observe, for example, if there is a 3 resistors is given, if 3 resistors is given, or we'll take some n number of resistors is given, so whose resistance is equal or unequal, so that is secondary. So let me take R1, R2 and R3. So now, like that it will go up to Rn, let me take it. Now, so basically these resistors we can connect always in two different patterns. One is in either in series connection and another one is in parallel connection. So for example, series connection I connected across a potential difference of, let me take example I'm saying. So potential difference of 5 volts. So now R1, R2, R3 may or may not be, may or may not equal. Means in the sense of what? Maybe R1 equals to R2 equals to R3, or R1 is not equals to R2 is not equals to R3. Then also either R1 equals to R2 equals to R3 or R1 equals to R2 not equals to R3. Then also we all knows that in series connection something is always remains constant. What is that? Everybody? In series connection, who is remains constant? Current remains constant. Is it right, guys? So now, for example only it is. So the total current passing in this circuit, the total current passing in this circuit with values also will do it, which is equals to, let me take for example, I is equals to 2 ampere. Do you all understand what I'm saying, everybody? So 5 ampere, 5 volts potential difference and some X R1, R2, R3 resistors are connected in series connection. So now what is the maximum current passing? Everybody? 2 ampere. So across R1 also 2 ampere, across R2 also 2 ampere, across R3 also again 2 ampere, remains same. So now even though they are same resistance or not having same resistance, as the same amount of current is glowing, so they all will glow with the same brightness. Same brightness. Do you understand? Now, instead of three three bulbs, if suppose I increase the bulbs, increases or decreases the bulbs. Now the question is to you guys. So of course, series connection current always remains constant. But suppose if only two connected, two bulbs, suppose here. So only two I connected, then still the supplied voltage remains 5 volts. Now my question to you guys, is the current remains 2 amperes or it may varies? Anybody? That is the question. All of you. Is the current remains 2 amperes or it may varies? That is what is my question. Everybody? Of course, current remains constant. Current remains constant. I'm not saying that. But that current remains 2 amperes. That is what is my question to you. Is it remains 2 amperes? I am asking. Whatever you feel, you can say. So that current remains constant, but it is not 2 amperes. Do you understand, everybody? Sir, why, sir? But brightness also. Of course, both R1 and R2 with the same brightness. Same brightness. Do you understanding? But this brightness is not equals to when they connected in three bulbs when they connected. So here brightness is same, but this brightness and this brightness is not equal. Not equal. So that is what you have to remember. Sir, how, sir? Let us prove that now. Okay. So let me consider R1, everybody solve, then we'll go to parallel. My yesterday nothing, you know very well, sometimes it has happened for me. So that's the reason. So that's even what I'm writing also, I don't know. So that's the only reason it is. So some people are enjoying, laughing. That's fine. It is. I'm not taking anything. So sometimes it will be happen for me. That's okay. So now, all of you observe. Let everything go with the question. Let R1 equals to 1 ohm. R2 equals to also 1 ohm. R3 equals to also 1 ohm. So those who are feeling anything, sorry for that. So just I'm saying it. So now let me consider the supplied voltage is, let me take 2 volts. Do you understand everyone? So this is the question. Now how many bulbs are connected? Everybody? They may be same or different, doesn't matter for us. Now what is the equivalent resistance, everyone? What is the equivalent resistance, Amma? R1 plus R2 plus R3. So which is equals to how much, guys? 3 volts. Yes. And what is the supplied voltage? Supplied voltage is 2 volts. So now the total current or current across every resistor. So in series connection, current across every resistor remains what? Everyone. Current across every resistor remains what? Everybody?
False.
Constant. So total current is equals to, what is the formula, everyone? Total voltage divided by total effective resistance, which is equals to 2 volts divided by 3 ohms. So what is the current, guys? Please let me know. Make it fast. What is the value of current? 2 by 3. How much?
0.67.
0.67. 0.67 amperes. So now 0.67 amperes current is passing across every bulb. So definitely all the bulbs, same current is passing. So same brightness will be there. Will you all agree with me? Everybody? Yes, please. All of you? Please respond, guys. Mr. Guru and Hare Krishna. Now, only I connected two bulbs. Two bulbs. R1 is equals to 1 ohm. R2 is equals to 1 ohm. Now, across the same potential difference. Across the same potential difference. Now you observe very carefully. The supplied voltage is 2 only. Now the R effective is equals to 1 plus 1, which is equals to 2 ohms. And the supplied voltage is also 2 volts. Then what is the total current passing in the circuit? Everybody? Total current passing in the circuit. V divided by R, which is equals to 2 by 2, which is equals to how much, guys? 1 ampere. Do you all understand? So now the current passing in the circuit, current passing in the circuit is equals to 1 ampere. Check it, everybody. So of course here also current remains constant, but here 1 ampere current, here only 0.67 ampere current. So what will happen? So which one, when in which case bulbs will glow brighter? When 1 ampere current is passing or 0.67 current is passing? That is my question to you. Everybody? Say what is current increases, so brightness also what? Current increases, brightness also what, Amma?
Increases.
Brightness also increases. That is what. Understand, Aishwarya now, Hare Krishna? But that constant is remains same. When when 1 ampere current passes across every resistor, same. So R1 bulb also same glow, R2 bulb also same glow, even though they are equal resistance or unequal resistance. But number of resistors, now I want to say the statements. The first time you all maybe listen. If the number of resistors reduces in series connection, equivalent resistance also reduces, amount of current increases, brightness also increases. Once again, I'll repeat. In series connection, current remains constant, but number of resistors connected in the series connection decreases, amount of current increases. Do you understand? So the brightness also increases. That is what you have to remember. Clear? Now, Mr. Harish, Mitakshri, Mr. Guru, Hare Krishna.
Yes, sir.
Yes. Anyone having any doubt in this? You can ask. Clear, everyone? So this is what is the concept. So remember, everyone, in equivalent resistance, in series connection, number of resistors increases, effective resistance also increases, but amount of current decreases. number of resistors decreases, effective resistance decrease, amount of current increase. So this is only the concept which I want to say. So hope you all understand. Anybody having any doubt, please let me know, or else I'll proceed. Is it okay, guys? Aishwarya, now clear? Yes, please. Any doubt, anyone can ask. Okay. So this is the most important concept. That's a very good question actually. Uh, Slightly sometimes it does fun. So that is what. So now we'll go with the parallel connection. So parallel connection, exactly what we studied in yesterday's class. So let us discuss now. So here you remember, all of you, in series connection, number of resistors decreasing. The current passing through the each resistor, increasing or decreasing? Current. Number of resistors decreasing. Amount of current is what? Increasing or decreasing? Everybody.
Increase.
Increasing. But in parallel connection, it is ulta, opposite. That is what with experimentally also will prove. Now, everybody observe. If there is a three resistors which is connected in parallel connection, maybe they are equal resistance or the same resistance. So let us whatever it is. So that is what is like extra exact question. So now you have been connected across the some potential difference. So some potential difference V. So now if they all are identical resistors means identical. Identical means their current is what? Of course, identical means R1 is equals to R2 is equals to R3. Identical means does not mean that R1 is equals to 1. It is wrong. Identical means they are having same resistance. That's all. So now the total current produced in the circuit is I. So now this current will pass, this current will goes. So it will splitting across the R1, I1, across the R2, I2, across the R3, I3. So that is what you have to remember. So now all of you observe with the experiment will make it. So like as yesterday's given question, that is what? The supplied voltage is 4.5 volts. Okay. And all are identical resistors. Then what else they have given the information? Everyone, anybody? What is the question number? It is question number 28. Is it right? Yeah. So let us go to that question and then we'll come. Question number 28. So all of you observe. So question number 28 you all can see is, so they are saying that which bulbs will glow brighter and which bulb will glow less. So first one. So B1, B2, B3 are the identical bulbs which are connected as shown in the figure. And when all three bulbs glow, the current of 3 ampere is recorded by the ammeter A. So the main connection. So maximum current is 3 ampere when 3 bulbs are glowing. So now, if you notice the first question, what happens to the glow of the other two bulbs when the bulb B1 gets effused? So this one, they are saying that brightness does not changes. But you cannot say, you have to prove it mathematically. Then only you will understand that. So many people may think that one bulb is removed means the current remains constant. So that current may increases. So the brightness of the bulbs increases. So but that is not true because we will go back to that and we'll come out. So now let us see when three bulbs are connected, all of you observe, when three bulbs are connected, identical bulbs or whatever it is, maybe R1, R2, R3 equal or may not equal. We don't know. Doesn't matter for us. So what is the maximum current? Everybody, ammeter is recording. What is the maximum current? Everyone. Maximum current is equals to how much, guys? 3 ampere.
Yeah.
Okay. So they all are identical dimension. So from that, I know total current and total supplied voltage. So I'll find the total effective resistance. So total effective resistance is equals to total current divided by total voltage divided by total current, which is equals to 4.5 divided by 3. So which is equals to 445 divided by 30. So this is what is the effective resistance, total effective resistance. Do you understand, everybody? So now, if you notice it, Now only two bulbs are connected. So two bulbs are connected means now let us see what is the resistance of one bulb. So three identical bulbs 45 by 3. So 45 by 3 means what amount 15 table for 3 is a and 2 is a. Is it right guys? 3 by 2. So which is equals to 1.5 ohms. The total effective resistance is 1.5 ohm. So we all know in parallel connection 2 points you have to remember. So what is the parallel connection? What is the first point you have to remember? Everybody, point number 1. What is the point number 1? Potential difference across every resistor remains what? Remains what
Constant.
amount? Remains constant. Okay, that is the first thing. Next, second point. Second point is, point number 2 is equivalent resistance is always less than individual resistance. Do you remember? If R1 equals to R2 equals to R3 and so on, always which is greater for us? Individual resistance. Individual resistance is greater than total resistance or effective resistance. Is it right? All of you all knows that. Am I right or wrong? Please respond. Everybody. So
Yes, sir.
three resistors. The three resistors value is 1.5. Then resistance of one value. So all resistors are same. R1 equals to R2 equals to R3. So we all knows the formula. What is the formula? My effective resistance formula. So RE is equals to R by N. Am I right, Amma? This is only the formula. Is it right, guys? Do you remember in parallel connection? Yes or no?
Yes, sir.
So the individual resistance is equals to effective resistance into N. So N is equals to how many guys now? In first case, N is equals to how many? 3. So the
Yes.
individual resistance is equals to effective resistance into number of bulbs is 3. So which is equals to 3 3s are 9. 9 by 2 which is equals to 4.5 ohms. So now all of you clear guys? Anything wrong, Hari? No, okay? Mitakshri? Is it clear?
Yes, sir.
Yes, sir.
Now, so all of you observe, now we found that each are identical. So total current is 3 ampere. So now current across every one resistor will find it. So that is common for us. So we all know if R1 is equals to R2 is equals to R3 in parallel. See, very clearly you make clarity, then only you proceed. If in parallel, if R1 equals to R2 equals to R3, then I1 is equals to I2 is equals to I3 because they are what? Identical. Am I right or wrong? Everybody? So identical. So I1 is equals to, now I'll find. I1 is equals to what? R1 by V. So R1 value how much guys? Individual resistance how much? 4 by 4.5 divided by total potential difference also 4.5. So which is equals to 1 divided, sorry, reverse. V by R1. Okay. So V by R1. So values are remain same. So 4.5 ones are 4.7 ones are. So what is the current passing across R1? Everybody? Current across
1
R1, 1. So I1 is equals to 1 ampere. I2 is equals to also 1 ampere. And I3 is equals to also 1 ampere. So that's fine. So each one, they are same identical resistors. So current passing across everyone is 1 ampere, 1 ampere, and as well as 1 ampere. That's fine. Now, so first question, if bulb 2 is fused, so then what about to the brightness of these two things? That is what they are asking. Brightness of the two other bulbs. So that is what bulb 2 gone means. I can say directly ammeter 2 reading is what? 0. Is it right guys? Everybody? Yes, please. Ammeter 2 reading is 0. Now, if the two resistors are connected, my question to you guys is the total current is remains same? That is only the question. Sir, only two readers. Let me take A1. That is what is the bulb 1 and bulb 2 fused. Bulb 2 gone. So A2 is equals to 0. So that bulb 2 is fused. Fused. And now third bulb. So A3 it is. So A3 bulb and only now what is how many bulbs are working? Everybody? Only how many bulbs are working? two bulbs are working. That is what R1 and R2. So now supplied potential differences remain same and this is the total current. Now my question is total ammeter reading remains same. That is what we have to check it. So we have to verify. So first question answer they are saying that B1 and B2 remains glow with the what? Same brightness. Yes or no? All of you? Yes, please.
Yes, sir.
Yes. So same brightness means same current is passing. So let us verify that now. So if you all check it now, so still supplied voltage is what? 4.5 volts. And we got R1 value is, what is R1 value? 4.5. R2 value is also how much, guys? 4.5. Now if you see, only two bulbs are connected now because one is fused. So only two bulbs are there. Only two bulbs. Then what is the effective resistance, everybody? Yes, please. What is the effective resistance? Effective resistance is equals to individual resistance divided by N. Now, individual resistance is 4.5. Number of bulbs are 2. Then what is the effective resistance? Everyone, please speak. 4 point divided by 2. How much it is?
2.2.
Yes, please. What is the effective resistance? 2.25. 2.25 ohms. Before, what is the effective resistance? Everybody? Before, what is the effective resistance? Before, what is the
1.5.
resistance, Amma? 1.5. 1.5. And now, what is the effective resistance? Everybody. Now, what is effective?
2.2.
2.25. So now, effective resistance increases. So definitely total current will decrease or increase. Effective resistance increases. So total current
Decrease.
decreases. Do you understand? So that is what you have to remember. So what is the total current formula? Total current is equals to total supplied voltage divided by effective resistance. So which is equals to 4.5 divided by 2.25. How much, Amma? Everyone? 4.5 divided by 2.25. Just now we have done up, same numerical. So reverse if you do, how much will come? N is equals to 2
2
amp.
ampere.
So when three bulbs are connected, ammeter reading is 3 ampere. 3 ampere. Now two bulbs are connected. We got the ammeter reading how much? Yes, please. 2
2
ampere.
ampere.
So total current is 2 ampere. Now the bulbs are identical. So identical means then across R2 1 ampere current, across R1 1 ampere current is passing. So amount of current is remains constant. So brightness is what? Current is remains same. Current remains same because it depends on power. Depends on power in C parallel. So that brightness is remains what? Everybody. Brightness
Same.
remains what? Remains constant. So suppose even two bulbs are fused. A2 and A3 both fused. Still the A1 R1 will brightness is what? Remains constant because the current passing is remains same. Only effective resistance changes. Do you understand, everybody? All of you understand? So now you can find I1 equals to, we all know I1 is equals to I2. So I1 is equals to V divided by R1. So you'll find it. So V value is still 4.5. So what is the R1 value? R1 value how much, Ra? 4.5 only. So what is the current
4.2.
passing? What is the current passing?
1 ampere.
1 amp. That is what you have to remember. Is it okay, everybody? All of you? Yes, please. Now, to make you more clear, let us make it into four bulbs, four identical bulbs. Now you can check it, everybody. So four identical bulbs, if I have been connected, now you all of you verify. So you will understand the effective resistance concept. So check it, everybody now. So still the supplied voltage is same 4.5 volts. Same 4.55 volts. Okay. So now what will happen? We got it, everybody. Individual resistance, what is that, everybody? Individual resistance, how much? Individual resistance, how much, guys? 4.5 ohms. Am I right or no? 4.5 ohms. So now, if they connected in parallel connection, then effective resistance you see is 4. Now N become 4. Effective resistance is equals to individual resistance divided by understanding number n, which is equals to 4. So individual resistance 4.5. Effective resistance, number is also 4. So what is that? 4.5 divided by 4. How much is the answer? 4.5 divided by 4, which is equals to how much, guys? Effective resistance 1.125. 1.125 ohms. Okay. Now you find the current across, total current. So total current is equals to what? Total current is equals to total voltage divided by total effective resistance. Now do the total current equals to how much? Check it. 4.5 divided by 4.5 divided by effective resistance is 1.125. So how much is the answer? 1.125. How much is the answer, guys? Sorry, division. How many amperes now?
4 ampere.
4 amperes. Do you understand? So means across every resistor remains current is how many ampere? Each resistor, what is the remains current?
1 ampere.
1 ampere. So total current is 4 amperes. Do you all understand, everyone? Everybody clear, Amma? It actually. So in parallel connection, number of resistors increases, effective resistance decreases, amount of current increases, but the identical resistors current remains constant. So their brightness also remains constant. Anybody having any doubt in this concept, please let me know. I hope you all understand. Everybody, Mr. Hari Krishna, clear? So in series connection, please remember, series connection, number of resistors varies, effective resistors also varies, and the current also changes. But in parallel connection, number of resistors varies, effective resistance, like number of resistors decreases, effective resistance increases. Number of resistors increases, effective resistance decreases. So please write in parallel connection, in parallel, if that is what number of resistors you write. Number of resistors increases, then effective resistance RE will decrease. Then total current. What will happen? Total current will increase or decrease, guys? Total current what? Increases. Do you understand? Please respond. Total current increases. So if identical, if R1 is equals to R2 is equals to R3 is equals to R4, then current always I across every resistor remains same, remains constant if n is equals to 1 or n is equals to 2 or n is equals to 3 or n is equals to 4, doesn't matter, etc. R value, I value remains constant. That is what you have to remember. So brightness remains what? Remains same. You connected 4 also same brightness, 3 also same brightness, 2 also same brightness, even 1 also same brightness. So for example, I connected only one bulb where R is equals to 4.5 ohms and supplied voltage is 4.5 volts. Then what is that, everybody? It is only single bulb. So then R effective is equals to R, which is equals to 4.5 ohms. Then what is the total current? V by R, which is equals to 4.5 divided by 4.5. Still, what is the current passing, everybody? Still, what is the
1
current
ampere.
passing? 1 ampere only. So the brightness of bulb is what? Remains same. Do you understand, everyone? All of you? Harish, anything doubt in this? Clear, Amma? Abrami? Yes, Mr. Ashik? So this is what is the concept actually. So this much things is there. So just I want to clear. So anyone having anything doubt, you can ask me. So in parallel connection, the current passing across the every resistor remains constant if they are identical. whatever the number, either number is 1, 2, 3, 4, 5, 6, 7, doesn't matter. Number keep on increases, effective resistance decreases, okay, and current remains constant. So brightness is always remains constant. That is what I want to say. So what will happen now? So what happens to the glow of the other two bulbs when the bulb B1 gets fused? So B1 got fused. So still remains, what is the current passing through the B2? Same 1 ampere. B3 also same 1 ampere. So same current, same
Glow.
brightness
Brightness.
or same glow. Next, what happens to the reading of A1, A2, A3 and A when the bulb B2 get fused? So B2 fused now. B2 is connected to the A2. So no current will pass to the B2. So A2 is equals to 0. Now only two are working, A1 and A3. So A1 and A3 remains constant, 1 ampere. A3 is also remains constant, 1 ampere. Now total current, only 2 is passing. So across here I1, across here I3. Now I1 plus I3 equals to total current. That is what A. So which is equals to what? 1 ampere plus 1 ampere, which is equals to how many amperes, guys?
2 amperes.
2 amperes. Understand? Then how much power is dissipated in the circuit when all the three bulbs glow together? So power is equals to V into I. So total voltage is 4.5. All three are glowing. All three are glowing means what is the maximum current? All three glows means 3 amps.
3 amperes.
Okay. So 4.5 into 3. How much it is? Everybody.
13.
4.5 into 3, which is
13.5.